Hello everyone, welcome to this edition of ASE Calcutech webinars. I'm Shweta Bhatt, your host today. So just seeing that some participants are still joining, so let's give them some time to settle in. Before we begin, here are a few hygiene points. This is a listen-only webinar, so kindly ensure your microphone is muted and the video is turned off. If you have any questions or comments, please feel free to use the chat feature. We'll compile them and try to address them at the end of the session. If you run out of time, then we'll reach out to the participants on email. Today's speaker is Ms. Aparna Raghunath, Business Development Manager for Metering Services at Calcutech. She has been with the organization for 6 years now, and her chief interests are design and implementation of DLMS protocol solutions, consulting and training in protocols like DLMS, COSEM, etc. She has conducted trainings for organizations like CPRI, PGCIL, KSCB, ECIL India, and was also involved in the companion specification design for APAC utilities. Just a little more time for everyone to settle in, and I think we'll start soon. Yeah, we'll just begin now. I'll now hand over to Aparna for the session.
Thank you, Shweta. Hi, all. So now we'll get started with our topic for today, ensuring meter compliance through functional evaluation of DLMS meters. In this session, we will discuss the key features of functional evaluation, why functional evaluation is required, the best practices for functional evaluation, along with how it can be performed. Let's now dive into our session. Firstly, let's start by understanding what do we mean by the term functional evaluation of DLMS meters. The functional evaluation is a comprehensive testing process that helps us to verify whether our DLMS meters operate or function according to their design specifications and regulatory standards. The process involves checking various aspects of the meter's functionality to ensure reliability, accuracy, and compliance. In the illustration, you can see how an electric meter is connected in a testing environment to check its adherence to the companion standard. Now, you might be having a question. What do we mean by the term companion standard? We know that DLMS is the most widely acceptable protocol for metering. But each utility across the world would be having different requirements. And hence, based on the requirements, we can customize the DLMS protocol to meet the specific criteria of that specific country or utility. And this customized version of the DLMS protocol is referred to as the companion specification. And when we adopt a companion specification, it is essential to make sure our meters abide to the rules and regulations of both the DLMS protocol and the companion specification. This gets verified by the process of functional evaluation. We can confirm the compliance of the meter to the protocol and the companion specification through functional evaluation. Next, let's head to the objectives of functional evaluation. The first objective of functional testing is to ensure the resilience of the meter by validating if the meter is capable of handling unexpected conditions such as overvoltage, overcurrent, or power outage conditions. And by confirming this, we can confirm the tolerance of the meter. The second objective is the compliance, which is evaluated by verifying that the meter meets the regulations of the DLMS standard. Coming to the third objective, interoperability. We know that we would be having a huge number of meters communicating with each other and with other devices in an electrical network. Hence, it's critical to make sure these meters can effectively communicate using DLMS in the network. And this is ensured by the interoperability feature. The next objective is the reliability, which checks if the meter performs consistently under different operational conditions. Heading to the last objective, which is security, wherein we assess the meter's ability to protect data and communication against unauthorized access and tampering that our meters could be subjected to. Moving on to the key components of functional testing. The first component is the communication testing. In this testing, we will be verifying that the meter can send and receive data correctly using the DLMS protocol along with interoperability testing using different communication modules and systems. The next component is the compliance testing, which checks if the meter adheres to national and international standards, which helps us to ensure the compliance with a specific utility or regulatory requirements. Coming to the third component, which is performance testing. Here, we will assess the meter's performance under various conditions, including normal condition and unpredictable conditions, to evaluate the meter's response time and processing capabilities. Fourth is the security testing to ensure that the meter's data and storage are secure, which is done by testing the vulnerabilities that could be exploited by cyber attacks. The next component is the firmware and software testing to verify the meter's firmware and software operate correctly and can be updated securely. For this, we could check for different bugs or errors in the meter software that could affect its performance. And the last component is the resilience testing, which ensures the meter is functional under adverse conditions, contributing to the robustness of the system. By now, we have understood what is functional evaluation, its objectives, and key components. The next question is, why do we have to perform functional testing? And why is it crucial before meter deployment? Let's now discuss the importance for functional evaluation. The functionality testing is essential to ensure the quality, which helps in maintaining high quality standards for our metering devices. It helps us in ensuring regulatory compliance, making sure the meters comply with legal and regulatory requirements. Next important reason is the customer satisfaction. The testing will provide an assurance to the customers that the meters are reliable and accurate. Followed by this, we have market acceptance. A thorough evaluation will facilitate a greater acceptance in the market by proving the meter's credibility and reliability. Lastly, we have risk mitigation. Functional testing will help us to identify and mitigate any potential risks and issues before we move ahead with a large scale deployment. Next, let's look into the best practices that we need to adopt for performing functional evaluation. Let's discuss each of this point in detail. The first best practice is to define an evaluation criteria. By doing this, we can establish clear and comprehensive evaluation criteria based on the specific requirements and standards as those outlined in the DLMS specification. The second best practice is to use a comprehensive test plan which in detail covers all the aspects of meter functionality, including basic metering functions, advanced features, communication protocols, and interoperability. We need to include scenarios for normal operations, edge cases, and any potential fault conditions to make sure we cover all the possible scenarios in detail. Next is the data integrity and security check, which can be validated by verifying that the meter correctly records, stores, and transmits data without errors. In addition, we need to assess the security features to ensure data confidentiality, integrity, and authentication mechanisms are robust against potential cyber threats. Followed by that, we have performance-based testing. By conducting performance tests, we can evaluate the meter's response time, communication speed, and handling of simultaneous data requests. The meter is recommended to be tested under different operating conditions to check its performance under various scenarios. Fifth is the interoperability testing, where we need to check or verify the meter's interoperability with other devices and systems, including head-end systems and data concentrators. The compatibility is to be ensured with different communication medias to ensure the interoperability of the meter. The next best practice is the resilience or tolerance evaluation, which will test the meter's capability under various unpredictable conditions to make sure the meter is able to withstand random scenarios, proving or validating its tolerance or resilience. Followed by that, we have firmware and software update evaluation as a optimal procedure. Here, we can evaluate the process for firmware and software updates to ensure it is secure and does not compromise the meter's functionality. The rollback procedures in case of update failures also needs to be evaluated here. Next is the user interface and usability. A detailed evaluation of the user interface is to be performed for assessing the ease of use, clarity, and accessibility of the meter. We need to make sure the meter's display and configuration settings are user friendly and provide all the necessary information clearly. Moving on to the next recommended practice, which is the compliance and certification verification. to ensure the meter complies with all the relevant regulatory and industry standards. The last benchmarking practice to be adopted is a detailed documentation and reporting throughout the entire phase of testing. We need to maintain a thorough documentation of all the test procedures, results, and any issues encountered while testing. The detailed test report can then be evaluated for further improvements or corrective actions. Having discussed the best practices, let's now outline the steps involved in the process of functional testing. The first step is the preparation stage. In this phase, we will have to define the evaluation criteria and prepare the necessary equipment and tools, along with developing a detailed test plan that outlines the procedures. Mainly, we are deciding how to perform this testing. After once this stage is completed, we can then get started with the initial round of testing to conduct preliminary tests to ensure if the meter is functioning as expected before we move ahead with a detailed evaluation phase. Followed by that, the third step is the detailed testing phase, wherein we perform in-depth tests based on the test plan based criteria, followed by recording and analyzing the test results to identify any deviations from the expected performance. The next step is the analysis and reporting phase, where we can analyze the test data to determine if the meter meets the required standards and specifications included with the compilation of a detailed report highlighting the findings, including any issues that we have detected and recommendations for improvement. The final step is the validation stage. If the meter passes all the tests, we can then validate the results obtained, followed by its deployment in the network, which is the final stage. We have now learned the step-by-step process to be followed for functional evaluation. The next challenge is how do we execute these step by step procedures to perform functional testing? Here comes the role of our AC DLMS FET tool or the functional evaluation tool, which will help you to evaluate DLMS meters for its conformance to the companion standard and ensure our meter implementations are following all the rules and regulations of the standard. To understand more, let's head into the key features of the AC DLMS FET tool. One of the important distinguishing feature of FET is that the FET tool is fully automated. The entire step-by-step functional testing process, which we discussed earlier, is automated by the FET tool. Now, why automation is extremely important when it comes to functional evaluation? Automation ensures to eliminate any chances for human errors, ensuring consistent results every time. It also saves time as automated processes are generally faster than manual operations, significantly reducing the time required for test completion. Apart from these, it increases the efficiency and consistency, providing high quality results without variations. Therefore, by automating functional evaluation, FET guarantees an efficient and error-free testing of your DLMS meters. The tool also provides around 100 plus test cases which are prepared based on the companion specification based test plan. This makes sure every rule and regulation in the specification is covered in detail during the testing. On the other hand, if manual testing is performed, there are chances that we might miss testing important criteria or rules. But with FET, you can be assured that the entire specification is covered for the evaluation of each individual DLMS meter that is evaluated with the FET tool. In addition, the tool offers support for HDLC, Mode E, UDP, and TCP communication protocols with added support for IPv4 and IPv6 addressing modes. The tool also offers a very user-friendly interface, which helps you to easily get started with the tool for your testing. Another highlight of the tool is the support for basic functionality tests such as object model verification tests to advanced functionality tests such as security testing, alarm trigger tests, event detection, and so on. We'll discuss the testing features in detail in our next slide. Now, let's discuss the testing features that are offered by the FET. The first test category that is offered under the basic category is the object model verification testing, where we will be checking if all the objects are present in the meter with proper access rights. According to every companion specification, there could be a list of objects which are expected to be present in the meter. And those objects are required to have specific privileges specified in the companion standard. So here we are checking if all the objects that are recommended by the companion specification are present in the meter along with the provisions or access rights that are given to each of these objects are being evaluated to check if it matches the companion specification. Coming to the advanced categories, we have security testing for checking security policies and security suites that we have configured in the meter. Firmware upgrade tests are also supported to ensure image transfer functionality that works in the meter, which will help us to incorporate latest firmware updations in the meter even after deployment in the network. Meters could undergo certain bug fixes or enhancements even after we incorporate the meter to the grid. And with the help of firmware upgrade or image transfer, we can ensure the meter is updated to the latest changes and enhancements. And this is evaluated under the firmware upgrade testing category. Next, we have disconnection testing to check the remote accessibility of the meter from the head-end system. Let's say if we require to disconnect a user from the grid since he has not paid his dues within the expected deadline. We can then make use of this disconnect feature to disconnect the user from the network. So, this remote accessibility from the head-end system to the meter is checked under this category. Under alarm triggers, we can verify if our meters trigger or generate alarms as expected. There could be unexpected scenarios that happen in the network. There could be voltage sag or surge or power outage, which could be happening and which requires alarm triggers. So we are checking if the correct alarm triggers are being sent by the meter to the respective events that happen. Next is the limiter functionality, which will help us to monitor certain parameters of the meter and perform actions such as disconnect if an over threshold or under threshold scenario occurs. Under the limiter object, we have the provision to add an object which needs to be constantly monitored. Let's assume if we are adding a voltage register under the limiter, specifying its boundary limits. So if a sag or surge happens, we can then perform necessary actions to bring back the value to the expected range. So we are checking if this functionality works fine or as expected under the limiter functionality test category. Next is the event detection and logging. We will be triggering events to check if the events are detected and if it gets logged into the corresponding event logs as specified in the companion specification. Lastly, we have tariff switching functionality test to check the functionality of IC20 or activity calendar. By configuring different tariffs with multiple season profiles, week profiles, and day profiles, we can evaluate if this tariff switching functionality is working fine according to the execution time that we have set in the meter. Now that we have seen the testing features of the FET, let's discuss how to perform testing with the FET. This is an overview of the testing environment. Here you can see a meter is connected to a test PC with the FET application already installed. After once this is done, we are required to give FTI or the functional text information file. This file will contain information of the meter that we are testing, including its keys and security policies. And along with that, we are required to select the tests to be performed on the meter. And once these are done, we are ready to get started with the testing. Followed by the testing completion, we will be provided with a detailed output folder comprising the report with the test result along with a log and traffic file corresponding to the tests conducted. Let's discuss each of this step in detail with a walkthrough of the FET application. We would be going through slides which discuss each of these steps in detail. Along with that, we would be performing these steps on the FET tool also. So this will help you to have a clearer understanding of the tool and its working procedure. After once we complete the installation of the FET tool, on opening the tool, we will be prompted to input the username and password. On filling, we can then select the amendment and part of the specification that we wish to proceed our testing with. Here, for our illustration today, we are using the Indian FET or the FET that evaluates the meter's compliance to the Indian companion specification. Similarly, we have FET designed for multiple companion specifications. And those FETs would be checking the compliance of the meters to that specific companion specifications. We are already supporting FETs which evaluate the compliance of the meter to multiple companion specifications around the world. Now coming to the Indian companion specification, the IS 15959 or the Indian companion specification is divided into three parts. which deals with each type of meter. Part 1 of the companion specification deals with static meters, Part 2 deals with smart meters, and Part 3 deals with transformer operated smart meters. So, according to the meter that we wish to evaluate, we can choose the respective part accordingly. Below, support for revisions are also provided. These parts, after their initial release, could undergo certain changes, which are referred to as revisions or amendments. And these amendments are also integrated to the FET to make sure the meters are evaluated according to the recent recommendations in the companion specification. So from here, you can understand that the FET is constantly updated to accommodate each and every revisions that happen in the specification. And according to these revisions, new releases of FET with the latest changes will be delivered to you. Now coming back to the login prompt, after we fill in these details, we can click on the login option to continue. On successful login, we will be taken to the UI of the application. Here we have multiple options. The file option, view option, and a help option to guide you with the use of the FET tool. Followed by these options, we have Open FTI option, configuration settings, and a start test option. Let's now discuss these steps with the FET. So this will help you to have a clearer understanding. After we open the application, we will be getting this login prompt, as we discussed earlier. And here we can give the username and the password. Giving the password, followed by that we can choose which part of the companion specification we wish to proceed our testing with. Here we'll go with part 2. So we will be checking the meter implementation to its compliance with part 2 of the Indian companion specification, which is exclusively for smart meters. We can also choose the revisions. We'll go with amendment 2 for the time being, and followed by that, after we fill in these details, let's click on the login option. On successful login, we are taken to the UI of the tool. As discussed, we have options such as the file option, a help option to help you get started with the tool, followed by the Open FTI option, start test option, and configuration settings. Now, let's see what are the next steps that we need to perform to get started with our testing. One of the first steps to get started with the testing using FET is to load an FTI file. Now, what is the FTI file? The functional text information file is a text-based file which contains all the information related to the meter to be tested, such as its keys, security policies, and security suites. Uploading the FTI file is the first step also to get started with the meter testing using FET. It is essential to make sure that we load the correct FTI file, as FET will be trying to communicate with the meter using the details that we have given in the FTI file. And the FTI files will be delivered along with the FET setup and will already have all the details such as number of associations, security policies. All of these will be already configured as per the companion specification. So the only change required is to update the meter keys as per the meter under test. Each meter would be having a unique key associated with it. So accordingly, we can change the keys. That would be the only step required. After loading the FTI file, the next step is to choose the test cases. These test cases are prepared as per the companion specification that we are going to test. And it will cover all the rules and regulations in the companion specification. Here on the left side, you can see the test cases prepared as per the specification. In our case, the Indian companion specification. And on the right side, we have the test cases supported by the FET. You can see on observing all the test cases as specified in this spec-based test plan are supported by the FET tool. And from here, we can either select all the test cases or go with the required test cases. If we opt all the test cases, then all of these tests would be performed in the meter. And on completion, we would get a consolidated report covering the test result for each individual test case that we have performed. After we select the test case, we can then go to the communication settings. Serial and IP mode are supported here with IPv4 and IPv6 addressing modes. Now we'll see these steps which we have discussed with the FET tool. Going to our FET tool, as discussed, the first step to get started with our testing is to load an FTI file. And this can be done by clicking on this Open FTI option. Clicking on the Open FTI option. Here you can see for every part of the companion specification, there is an FTI file that's already delivered along with the setup. And from here you can choose which part of the companion specification that you are going to test. Here we had opted for part 2 during our login. So we are going to go with the FTI file for part 2. We are loading the FTI file to the FET platform. And in this FTI file that is loaded, you can see the number of associations that are expected as per the companion standard, along with authentication mechanisms, its keys, its security policies. All of these details are mentioned in the FTI file. And the only change will be to change these meter keys accordingly, according to the meter under test. If there are any changes required, we can make the necessary change and then click on the Save FTI option. So from the next round of testing, the modified FTI will be used for further testing. After we load the FTI file, the next step is to go to this configuration settings option. Here we are going to select the test cases. So these are the test cases prepared based on the companion standard. And if we want to select all of these test cases, we can then click on the select all option. So all of these cases would be performed on the meter and we would be getting a consolidated report indicating the test status for each of these tests performed on the meter. But if we want to go with a specific case, we have an option for that as well. Out of this, let's say if we want to go with the nameplate details category, we can simply select that option to get started with our testing. And under this test category, we will be checking if all the nameplate parameters that we are expecting as per the companion standard are available in the meter. After we select the test case, the next step was to go to this communication settings option. Here, as discussed, we have support for serial and IP mode of communication. For the time being, let's go with IP mode of communication. You can also choose between IPv4 or IPv6. We'll go with TCP. UDP is also supported by the FET. Below, we have to give the IP of the system where the FET is being hosted. Next field is the IP address, wherein we are required to give the IP of the meter that we are going to test. Now today, for our illustration purpose, We would be using the AC DLMS Meter Simulator tool, which is an application that helps us to virtually simulate up to 1 million meters. Meters of any companion specification can be simulated using the simulator tool. Here, we have designed a meter abiding to the Indian Standard Part 2, and we are checking if this meter implementation that we have designed using the simulator is fully following all the rules and regulations of the specification. We have already had a webinar discussing the importance of simulator in the HES performance benchmarking. The simulator is capable of mimicking a large scale meter simulation environment, which makes it extremely useful for HES performance tests. You can contact us for more details on this webinar. Now, coming back to the FET, here we have given the test case and we have also selected the communication parameters. After that, let's click on the OK option. Now, going back to our slide to check the next process that we need to perform. So far, we have loaded the FTI file, we have selected the test case, and we have configured the communication settings. We are now ready to start our testing. So these are the configurations. These are the only configurations required. After this, on starting the test, we will then get a report settings request. Here, we can fill in the details to be included in the report generated. The manufacturer name, serial number, rating, all of these can be given here. We can also choose a path for saving our report, and all the details of the test conducted will be available in this path for any future reference or analysis. After we fill in these details, once the test begins, the test result will be available for the user. Here, we are performing a nameplate test category wherein we are checking if the meter displays all the nameplate parameters correctly, such as serial number, firmware version, rating, and device ID. Now, after we view the test result, if the tester is expecting some more parameters or has some suggestions for improvement, in that case, the tester can select the verdict as fail and he can note down the improvements to be made. So, this added feature is also provided by the FET, wherein the user can choose the verdict apart from the verdict already prepared by the FET. If the user is having an additional input, he can choose the verdict apart from the verdict already given by the FET. After this, we have an option to add any remarks or observations that has been found or observed by the tester during the process of testing. Let's now see these steps using the FET. Going back to the FET tool, we have already loaded the FTI and we have given the test to be conducted, followed by the communication settings. We are now ready to start our testing. The meter is also simulated with the simulator application. So let's click on the start test option to get started with our testing. This is the report settings preview. Here we can input details such as test house name, serial number and model name as already discussed, followed by the output folder path. There is also an additional option called as the password enable. Now this option helps us to enhance the security for the test reports that are generated. If we enable it, only the people who are aware of the password can then access the test report that is generated. Going ahead with the testing by clicking on the OK option, we are starting the test and this is the preview of the result that we get. Here we are reading it from both the nameplate profile as well as individually. And you can see every parameter is coming as expected from the simulated meter. Confirming this as a case of pass. Here we have the observations and comments tab wherein we can input any remarks or feedbacks found during our testing. Confirming it, we can review the observations made, followed by saving the output folder for the test conducted. Let's now see what are the next steps that we need to check. For displaying the log and traffic associated with the test, we have a separate tab called as the log traffic. And in the log that gets generated, we would be provided with all the details of the test conducted, including the step-by-step information with the timestamp. So this helps us to know what has been done by the FET for executing a test and what are the results received for each step, which indicates the meter's response to each step. Coming to the traffic, in this file or in this preview, we will be getting the information related to the packet exchange happening during each stage of communication. The packet information comes with timestamp and it can be easily compared with the log file to analyze what has been the response for a particular request made by the FET. So this helps us to debug any communication failures that could happen during our testing. On test completion, we would be getting a detailed report as well with the test status indicated as pass or fail. Now, if it's failed, we will be provided the reason of failure, which helps us to easily diagnose the reason of failure to rectify our issue. In addition, all these test details are available in the output folder generated, which helps us for any future analysis. Now we'll see these with the FET. Let's go to the log and traffic. And here we have the log generated for the test that we have conducted using the FET. And here in the log that gets generated, you can see each and every step that has been performed by the FET is mentioned in detail in the log, starting from the AARQ establishment and reading of the nameplate parameters. All of these steps that are performed by the FET is mentioned in detail in the log, and it also comes with the response received from the meter, which helps us to know if it's a pass or fail or if it has been successful. In our case, you can see the get is successful for all the nameplate parameters, which is why the test has been marked as a case of pass. It abides to all the rules and regulations that are required as per the nameplate category in the companion specification. Below, you can see the traffic that gets generated for this test. Here, along with the timestamp, we have information related to the packet exchanges that are happening to each and every step that we are performing. It is also color coded, which helps us to easily identify. The red indicates the requests made by the FET to the meter, and the green indicates the responses that we get back from the meter. We can also compare the traffic timestamp with the log timestamp to know what has been the packet exchange for a particular step conducted, which helps us to easily diagnose any issues and rectify it. Coming to the report, here we have information related to the test house, the date and time, the manufacturer name. All of these informations are available here. Followed by that, the result for the category of the test that we have performed. Here we have performed a nameplate category test, and you can see the verdict that has been generated for each of the sub tests that has been provided under this category. We can also see the output folder that got generated. So this is the output folder that got generated for the testing that we have done. Similarly, for each and every test that we perform with the FET, a detailed output folder will be generated, which helps us for any future analysis or references. So these are the contents inside the folder. We have the FTI file, the log file, a report file, and also a traffic file indicating the packet exchanges. So this helps us for any future references as required. And it will be saved for each and every test that we perform with the FET tool. Next, let's see a sample test report that is generated with the FET. In this sample test report, you can see we have details such as the manufacturer name, category name, serial number, firmware version, along with the test start time, test finish time, the tester details. All of these informations are available in the test report. Below, we have the number of test cases performed indicated with the result. Out of the 4 tests that we have performed, 3 have passed and 1 has failed. Here we are evaluating the FET with a different companion specification on the meters following that respective companion specification. So you can see the test groups that we have under that companion specification, which is the security test category. And under this category, we are expecting 4 subtests. And out of the 4, 3 have passed and 1 has failed. The encryption key transfer has failed on that particular meter implementation for a particular companion specification. Now below you can see a detailed test failure information. Here we'll get the information as to why the test case has failed. Let's check the reason of failure. Here you can see, according to this companion specification, we are expecting a frame counter reset after the encryption key transfer. And due to a hardware fault of the meter, this has not happened in the meter as we are expecting as per the companion specification, which is a deviation from the standard, which is why we have got the verdict as failed. So from here, you can understand how strictly FET monitors each and every rule and regulation of a companion specification. And in case of any minute deviations, the verdict will be marked as failed for us to review and take necessary actions to resolve it. So it helps us to fully verify the compliance of a meter implementation to a companion specification, covering all the rules and regulations of that particular companion specification. By now, we have discussed what is functional evaluation. We have discussed why it's critical to be performed before we move ahead with the deployment and how it can be performed with the FET tool. Thank you all for attending the webinar today. Please let us know your questions.
Yeah, thank you, Aparna, for that informative session. We have some questions from the audience and take it one by one. It says Sonal is asking if functional evaluation can be replacement of conformance test tool or development test tool, and will it
Yes,
be able to save the files if all the test cases are checked during execution?
yes, all the files will be saved, including the FTI file, the traffic file, the log file. All of these files will be saved in an output folder, as we've already seen. And this is a replacement for checking the conformance of the meter, a total compliance check of the meter.
Okay, thanks for that. And there's another question from Abdul who says, for a water meter, what is required to be in compliance with the DLMS specifications?
Well, it depends upon the companion specification of that respective utility or country. Every utility could be specifying different rules, and accordingly, the rules might vary.
Okay. And Vinay says, please plan to provide a DLMS testing training, maybe in the future. So that's another one. And we have I think somebody wants to ask a question. Shall I take that? Um, yep. Okay. What are the tests specific to smart meters from security standpoint? Is a question by Balakrishnan.
We would be mainly having key transfer tests. Also, we would be having test cases which checks the security suits and security policies are configured as per the companion specification. Here is an illustration for the same. And this also again varies according to the companion specifications. Some companion specifications might require a broadcast key and some might not. So the test cases would be depending on that particular companion specification. And according to the companion specification, FET is fully customizable. According to your requirement, FET would be adjusted or accommodated according to your requirements.
Okay. Thanks. Just seeing some more questions here. I think Sony has a question, and so could you type that question if you don't mind, Sony? Yeah. You can ask your question. So, okay. Looks like not able to get it through. There's another one that says, how does FET manage multiple companion specifications?
For every companion specification, we'll prepare a companion specification based test plan, and that will cover all the rules and regulations of that particular companion specification in detail. So that's how we handle multiple companion specifications. We have FET designed to test the conformance of meters for multiple companion specifications. We start from identifying the test cases by looking into the rules and regulations of that companion specification provided.
Um, yeah, Marcin is asking, will you be sending this presentation? As I think it'll be available on the recording in the website. So, and we'll also share via email later on. So I think that's it. If any more questions, I think we'll just hang on for a couple of minutes and let us know your feedback also on the particular training. Anwar is asking if manual testing is possible with FET.
Yes, there is an added option which supports manual verdict as well. So if you think for a particular test case conducted, there is a scope for improvement or there are some additional parameters that you are expecting. In that case, manual verdict can be chosen. Apart from the verdict already generated by the FET, a manual verdict can also be added to the report. So this will override the verdict that is given by the FET. So there is an added provision for manual verdict selection as well.
Yeah, right. There are a couple of more questions here. Durga Shankar asks if could you please provide practical training with smart meter if that is possible? And Sundarajan says, when can we get the certificate?
These reports will be generated immediately after we complete the testing with FET.
How many meters can be tested at a time is Sony's question here.
According to the recommendation from the DLMS UA, one meter can be connected at a time to the FET for checking its functional evaluation.
So to answer the certificate regarding the question regarding the certificate, um, apart from the webinar recording link, participation certification will also be shared automatically after 24 hours to all the participants. And if you have any more questions, you could reach out to marketing@calcitech.com. I'll just share this on the chat. Okay. How many meters are connected at the RS485 loop?
We'll have
We still
one
have.
meter connected.
Okay. Thank you so much. I think that's all we have from the questions. If any other questions, please feel free to write to the email ID that I've shared on the chat window, marketing@calcitech.com. Thank you all for joining today. Thank you, Aparna, for this wonderful
Thank you. Thank you
seminar.
all.
Yeah.